Alright, in solving exponential and logarithmic equations for day 2, we're going to begin by looking at the calculator as a possible resource for finding solutions. So you'll notice that I've completed question number 1 for you already. Notice that y1 will contain 3 to the 2x power and y2 will contain 81. Change your window size. Notice that the window on the graph goes from 0 to 90 and from about -5 to +5. Once you change your window, you'll get this exact screen and you'll be able to see what is actually on the paper right now, and you'll understand how to find that appropriately. Again, when you put it into table form, you'll have x and then y1, y2, and you need to find where the y's are equivalent, which will be 81. Before moving on, please attempt question number 2 prior to viewing this portion of the video, just to get that practice down. Make sure you're using parentheses appropriately when you're putting logarithms in your calculator. Once you have completed it and you believe you have the solution, go ahead and unpause the video, move it forward, and check to make sure that you have done this correctly. The calculator can be a very useful resource for you, so it's important that you understand how to use it correctly in these situations. The solution to question number 2 looks like this. The reason why that's a horizontal line there is given. You'll notice that I've boxed in the logs, or the right side of the equation. I've simplified it using properties of logarithms, and when you simplify this using properties of logarithms, you get a constant, not a curved line. Because there's no variable in that result, that means the right side of the equation is a single number, and that single number is 0.477, or the log of 3. You can find their intersection point there, both in the table form and your graphical form as well. Today we're going to introduce a new form of solving logs, and in most of the new operating systems we can get around this new form of logs, but the calculators is doing exactly what we're going to do here. So if you don't have the new operating system on your calculator, you'll have to rely on this form. Questions number 3 and 4 will help us introduce the change of base formula, which is what you're going to use when the base of a logarithm is not 10. So in question number 3, there's going to be 2 possible ways to solve this problem. The first way takes us all the way back to the beginning of the semester, properties of properties of exponents. Once you make the bases of the exponents the same, you drop the bases and solve. Flash forward to the beginning of Unit 7. Use your properties of logarithms to switch from exponent form to logarithmic form and evaluate. So that's going to be log base 3. Whoa, log base 3. Of 27 equals 2x. And you evaluate this by determining what number, what to raise 3 to get 27. And that's going to be 3. In other words, looks like this. 3 to what power equals 27? And that is 3. So we've evaluated that part of the log to be 3, and then we change it, or solve for x after that. Okay, and this is the reason why the change of base formula is necessary. Number 1. Is there a number I can change 40 into that has the same base as the left side of the equation? The answer to that question is no. Over here, I'm going to go ahead and try to evaluate by switching into log form. log base 2 of 40 equals x. Well, this isn't friendly like this one. We can't raise 2 to a power to get 40. So enter in the change of base formula. The change of base formula states if you have a log with base b of x as its argument, you can change that into log base 10 form. You change it into log base 10 form by writing the argument x on the top of the fraction and writing the base b as the argument of the bottom of the fraction. Now remember, if it's not written in log terms, it is assumed to be base 10. So if you want to write out your base because you want to be clear in your mind every time, you can write it this way. If you don't want to write out your base because you understand that that's base 10, then you can write it this way. Regardless, the base of the logarithm always goes on the bottom of the fraction. I've used this to kind of help you keep that straight in your mind. So now what we're going to do is we're going to use the change of base formula to evaluate this particular problem. And it's approximately 5.32. You can just get that by typing in log of 40 divided by log of 2 using your calculator. Alright, questions numbered 5 through 9. I'm going to do questions 6 and 8. You're responsible for completing 5, 7, and 9 prior to class tomorrow. Please make sure that you're ready and able to explain and or solve these problems with your table groups tomorrow at the beginning of class. Alright, so we're going to switch into log form. Log base 7 of 21 equals negative x. I can't evaluate this logarithm because 7, there is no power that I can raise 7 to get 21. So I'll go ahead and use the change of base formula. Log of 21 divided by the log of 7 still equals negative x. Typing this into my calculator, I'm going to get an estimated answer of 1.565 equals negative x. That means that x must equal negative 1.565 approximately. The process is not very difficult. You just have to remember how to use the change of base formula effectively. Alright, question number 8. We'll go ahead and take a look at this first by adding a log to both sides. Remember, that's in the notes portion of your foldable that says if you have equivalent parts, then you can add a log to both sides and not change those equivalent parts. Now you'll see the significance of that in just a moment. D minus 4 equals log of 3 to the 3 minus d. Now the reason I needed to do that is because this exponent and this exponent need to move out. And the reason I did that instead of anything else is because there is no way for me to turn 16 and 3 into numbers that have the same base. If this was a 2, I wouldn't have to do any of this because the 2 could change. I could turn 16 into 2 to the 4th power. But I can't do that here. That's why I chose to add the log. Using properties of logarithms, I'm going to bring the exponent out in front. D minus 4 times log of 16 equals 3 minus d times the log of 3. Now I'm going to manipulate these logs by moving the logarithms to the same side of the equation. So in doing that, I'm going to divide both sides by log of 16. Now that I've done that, I can get an estimated solution right here. The estimated solution is going to be 0.396. I got that by just typing that into my calculator, times 3 minus d. And that's equal to d minus 4. I'm going to use the distributive property here, and I'm going to get that number inside and get approximately 1.189 minus 3.396 times d. Now I'm going to solve for d by moving all of my numbers around. I'll go ahead and add 0.396d to the other side of the equation. And I'm going to add the 4 simultaneously. Help me save some steps. So I get 1.396 times d equals 5.189. And now I divide that out. And I get d equals the approximate solution of 3.717. Again, please make sure that you're ready to answer questions. And again, if you have any questions about the solutions you're getting, utilize the first part of the notes by checking all of your answers in the calculator. It is a very useful strategy and a useful tool for you, so please utilize it to help make sure that you're doing it. Don't use it as a substitute for doing the algebra. Use it as a way to check to make sure that your algebra is in fact correct.